Go ahead.
Welcome everyone. I'm Vlastimil Babka. I work in SUSE Labs on the kernel core team, mainly on the memory management, the kernel. And in the previous discussion, you might have heard that actually Michael Hotsko was initially going to give this talk, who's my team lead, and uh, he also started as a student that turned to a kernel hacker later, but unfortunately he had to cancel his presentation, so we told that I would try this instead, even though my personal experience is, of course, a bit different as everyone's, but I will try to draw some generic conclusions even from that, and also tell you how the more common ones experience looks like, and also I will a bit substitute for another presentation that was supposed to be here by Hode, and about our collaboration with universities, because I think um, uh, somebody from the audience, I hope that maybe the majority would be one of students of one of these universities that we collaborate with, and might find this useful. Even though Hode is a university coordinator and knows best about the whole topic, uh, I have also some experience with parts of that, so I will talk at least about those. So I will start by answering maybe the question, why would you want to be a kernel hacker in the first place when you are a student and deciding what to do with your career and what to focus on. Then I will try to share my experience a bit, and also the ones that I think are more common. And I will also tell you a bit about what a day-to-day experience of a kernel hacker looks like, at least in the SUSE labs, and how we can actually help students that would want to be kernel hackers through our cooperation with Prague universities. So why would you want to be a kernel hacker in the first place? I think maybe the one prerequisite is that you need to have some appreciation for low-level code that's close to hardware, and if you find that interesting, then that's good for you to focus on. If you want to instead work with rich web libraries, then maybe this is too different for you to be a kernel hacker, because in kernel we don't almost deal with any user interface or even users like influencing anything, because the kernel should ideally work like reasonably well for anyone without much influence or tuning. Whenever there is some performance tuning decision to be like delegated to the administrator, it's always, we think hard about how to avoid it and make everything self-tuning as long as it's possible. It's not that we hate the users, but we know that it complicates things, because then if we add some user interface, it has to be supported basically forever, even though it doesn't make sense after further development changes things so much that the tunable doesn't work anymore. On the other hand, in kernel, our kind of biggest user is not the person, but the user space program. And for that, the main dogma of kernel development is to never break an API or ABI that would cause the user program to break. So that's really different from programming for people using software. And if you find this appealing, that you might want to be a kernel hacker. The modern language is of course a joke, because kernel is mostly written in C, some very low level part in assembler. The C standard is not even a new one with some more fancy syntactic sugar. On the other hand, maybe soon we will be writing some drivers in Rust, which is very modern, at least compared to C. And the reason is not to use something more modern, but to use something that's more secure and harder to write vulnerabilities in. The development tools and processes involved in kernel development are also not modern, because patches are sent by email. We also communicate on IRC. The most modern tool is maybe Git, and yeah, that's really a powerful versioning system. Just the UI is maybe difficult to get used to, but compared to email and other stuff, it's very high tech. And unfortunately, in memory management, where I work in the maintainer in upstream kernel for memory management still didn't switch to Git, so I don't enjoy this high-tech feature upstream, just in SUSE internal repositories. Then some people might be motivated to become kernel hackers because they think it will make them famous, because Linus Torvalds is famous, and doing kernel stuff must be some magic that only the best developers can do. That's actually not the case. So if some people just come to submit some white space or typo patch, typo fixes to the kernel just to have a patch record in the kernel, then it's often difficult to work with these people. So that shouldn't be your motivation. It's not It's not that different from any other programming. It is very specific, but there's no crazy magic in that. On the other hand, what might want to motivate you is that your code might run on all Android phones on the planet, or even on recently on the Mars helicopter. But for that, you have to be very patient, because the Android phone vendors are very slow to pick up new kernel versions, and even the NASA engineers used such old kernel that even though I work on it since 2013, the kernel they used on the helicopters is even years older than that, so I didn't get that GitHub badge, and that makes me very, very sad. So maybe in 10 years and another helicopter, it will have a more recent kernel. One kind of motivation that I like personally is to solve difficult bugs. Well, we had a presentation from Wojciech about very interesting ones. I could also talk about many that are some very difficult to uncover, memory corruptions, and that we had to solve just by looking at the crash dumps with our tools and figuring out what could overwrite the memory. And if you enjoy that kind of detective work, then this might also motivate you. What's really motivating is that if you work in kernel, but that also applies to the most of the open source, that really has a community, and it's not just a single company publishing a repository on GitHub, is that you don't work with just the people from your company, but in fact from many people from companies from all around the world, and then in the end, it's from the perspective, it doesn't matter which company employs you particularly, because it's a worldwide community, and you can also make many friends there, because there are conferences for the community that are now mostly virtual, but hopefully that will change next year to the good old days. We'll see. And yeah, you as a kernel hacker, I find that you have a lot of freedom to pursue your own ideas what to improve in the kernel. You don't have everything just prescribed by your employer. Of course, that depends on the companies. For example, if some companies I will not name are known that if some kernel developers go there, they unfortunately disappear from the upstream community and work on internal stuff. But SUSE is certainly not one of those. Okay, so now for the examples of journeys, I will briefly talk about mine, because that's really not a common one, I think. So yeah, I'm old enough that my first computer was an 80-bit computer which didn't have any operating system. Then on PC I had DOS. At the time Linux already existed, but because we didn't have internet, I wouldn't even know about it. And yeah, DOS was pirated by everyone else. And actually, in hindsight, I was already doing some memory management because there was this saying that 64 kilobytes is enough for everybody, but if you really want to have that 64 kilobytes free, you had to do some tuning with these high MEMSys and EMM 386 tools, and I don't know even how I did it, but I guess from some magazines I was able to use that and even do this kind of tunings for my friends. Then what was really important for me was the operating systems lecture and especially the semestral work at Matfis. I hope that some of you are maybe Matfis students and heard about this. It used to be mandatory, now it's not, but if you want to be a kernel developer, then, or at least see how it's like, then this is really useful, because there you have to write at least a portion of a kernel or on a very simple CPU from scratch or from very basic building blocks. And as it happens, in my case, our topic was also focused on memory management. And then to do master thesis, I became a Gentoo user first and then Gentoo developer, but didn't really do any kernel specific stuff. But it was enough to be noticed by Greg Kroag-Hartman, who is one of the top level kernel developers and was working at SUSE at the time, and suggested, and he was also a Gentoo developer at the time, and suggested that I could apply for part-time work as a student, which I unfortunately didn't act upon, and I wonder what would be different if I did start earlier and experience some of the earlier glory days. Yeah, then I had an experience with trying to fix a kernel bug that occurred on the machine I was using at the university. Unfortunately, it was in the ACPI code, which is very complex, so I didn't spend enough time to understand what was wrong, but at least I was credited for the bug report because I provided enough information. And then after I finished the studies, which, because it included PhD studies, it was longer than usual. It was very late, and I actually decided, okay, I will try to be a kernel developer because I was doing this low-level stuff most of the time, and this looks interesting. And I was lucky enough that there was an open position at the time, and what helped, I guess, even if I didn't have this prior upstream experience, is that I had this open source general experience from the Gentoo, because to some extent working in an open source community is similar, even if it's a distro or kernel. So it helps that if you have that experience. And yeah, because everyone at SUSE Labs went through the same operating systems course at FIS, they knew that who passes this course probably can can do kernel development, so that helped as well. But I noticed that some people do combine, this PhD studies with already doing kernel development in upstream at the same time, and in retrospect that might have been a better way, but there it is. Okay, now I will describe the more common way, which I think my team lead Michael Hotsko would describe, and it was already hinted at in the previous talk.
5 minutes, Vlastimil.
Yes, so I will just expand on that because, as Aleš said, in the L3 department you work on bugs, and it can be kernel bugs, and you can be exposed to various subsystems and pick your favorite, and it could be a kernel subsystem. And as one thing is that you, even if you are a new member of L3 and cannot solve the bug yourself, you interact in the same Bugzilla entry and can follow the analysis that the more experienced developers write in the comments as they debug those crash dumps. And I think that is great for learning how these things work. And then a time comes when a fix is simple enough for experience that even as an not designated developer, but still a support agent, you can write and submit it upstream, and increasingly more start interacting with the upstream kernel community, start doing patches for others in this area. And right now, for example, in memory management, we have one L3 guy who is one of the best experts on memory hot plug, even though he's still in L3 and not in labs. And also the labs conference for labs developers is generally open to everyone from L3. So it's, if you want to, it really can be a great way to become a kernel developer through the labs, through the L3 department experience. And it's really what happened multiple times in the past and will happen again, I'm sure of that. So just quickly, what do you actually do when you become a kernel developer? So you have the idea. So your responsibilities are split into caring for the distro and the company stuff, which means helping with the bugs, implementing fixes, backporting fixes from upstream, so they are included in the maintenance update before a customer hits those bugs. We also backport features and participate on general maintenance workload and help with tools. For example, I try to expand our crash debugging tool called Crash Python, and its ability to debug memory management issues in kernel crash dumps. And in the upstream kernel work, which can be really substantial part of your time, if there are no urgent bugs or features to backport, you can basically pick what you want to improve, become a subsystem maintainer, review patches from others, and really become prominent in the upstream kernel community. And we have, for example, specialized conference for memory management and related topics, and then you can influence the overall direction of the kernel.
5 minutes.
For everyone, not just your employer, but for the greater good. And the last thing, how can we help students become kernel hackers. So we have 4 years cooperation with Matfis and also the Czech Technical University Faculty of Informatics. And our participation is that we give lectures in the Advanced Operating Systems course, which is open to public and often also recorded, and you can find past ones on YouTube, which can be useful as an introduction to subsystems where documentation is outdated and the talk and slides can be much more recent. We also participated on the crash dump analysis course, but unfortunately there wasn't enough students interested in it last years. And what can really help is that we are advising semester projects and bachelor thesis and master thesis, not just on kernel topics, but also on kernel topics. And there have been instances where these students were hired afterwards, and it can also be a quick way to get some upstream kernel experience. For example, I'm now advising a student project about the slop allocator that where the student already submitted patches upstream, and it was only because of maintainer issue that they aren't merged yet, but they will be soon. So that's all for me. I spent a lot of time, so maybe there's still some time for questions, and if there are more, I will also try to join the later part where you can interact with the various teams, so you can ask also there. So thank you. And
perfect. Thank you, Vlastimil. Thank you for a presentation rich with information. And we do have some questions in the chat. We still have a few minutes to ask them. So Andy is asking, knowing the coding language C is probably a requirement to start with the kernel journey community, right? Can you confirm that?
Yeah. I mentioned that knowing.
Knowing, yes.
Knowing it. Yeah, you have to know C, but I think it's one of the simplest languages to know because there are no rich libraries and complex constructs. So that can be really learned quickly, and even getting used to the kernel style of C is, I don't think it's a big issue. And
You probably need at least the potential to learn it, I guess.
Yeah. That's
so if
maybe
you don't know it now.
Yeah, the development is constantly learning various details that you've remembered last week but forgot. So you have to read the source code again, and yeah,
Yeah,
this
I feel
ability
you,
is the most important.
I know what you're talking about. Right. Any more questions? Anybody wants to ask something?
There's something about slides. I guess I can upload them if we will have some page for uploading them.
You can probably then share them in the chat room part if you want. Yep. Anyone else? Any questions?